Hello everyone, I Puneet Upadhyay, HOD of Mechanical Department, handling the subject Computer Integrated Manufacturing. In the previous session, that is in session 6, we have discussed regarding the chapter Robotics. In that chapter, we have studied what is a robot, elements of robotic system, the importance of robot in industries, the robot configuration, 6 degrees of freedom, programming of robot, then programming languages for the robot, then end effectors, then the importance of industrial application of a robot, and most likely questions for the examinations. So in this session, that is in session 7, we are going to begin with a new chapter on the CNC part programming. So what will be covered in this session? The programming fundamentals, factors considered while writing part program, coordinate system, methods of dimensioning, various compensation for machine accuracy, axis and motion nomenclature, structure of part program, preparatory and miscellaneous functions, then fixed or cane cycle, subroutine, program on turning and milling operations, then most likely questions for the examination. Now let us start with the programming fundamentals. What is this programming fundamentals? So each machining involves an important aspect of a relative movement between cutting tool and the workpiece. So if you want a relative motion between the cutting tool and workpiece, the machining operations is been considered. So in machine tools, this is accompanied by either moving the tool with respect to the workpiece or vice versa. So this can be done by movement of the tool on the workpiece or the vice versa. In order to define relative motion of two objects, reference directions are required to be defined. So in order to move in any directions, the two reference point plays an important role. The two reference points is needed so that the tool moves in the respective directions. This reference direction depends on the type of machine tool and are defined by considering an imaginary coordinate system on the machine tool. So whenever the reference directions is given, it depends upon the machine tool and are defined by considering the imaginary coordinate system on the machine tool. A program defining motion of a tool or workpiece in this coordinate system is known as the part programming. Next, factors considered while writing a part programming. First one is the drawing of component must be analyzed, type of material used and its characteristics, type of coordinate system, jigs and fixture required, dimension type and units, type of coolant required, various compensation, sequence of operation required. So these are the factors considered while writing the part program. Next, coordinate system. So what is this coordinate system? So in an object which can move in any degrees of freedom, that is it has a 6 degrees of freedom with respect to the imaginary Cartesian coordinate system. So 3 of them are linear movement and 3 of them are rotary movement. So machining of simple parts does not require all degrees of freedom. With the increase of degrees of freedom, the complexity of hardware and programming increases. So as the degrees of freedom increases, that is from 3 to 6 degrees, the complex of the parts varies. Number of degrees of freedom depends upon the axis of machine. Axis interpolation means simultaneous movement of a two or more different axes generate required counter. The next, for typical lathe machine, degrees of freedom is 2, and so it is called 2-axis machine. The methods of dimensioning. There are two types of dimensioning. One is absolute dimensioning and one is a relative dimension. The absolute dimensioning is given by the G90 in the part programming of the CNC machine. What is this absolute dimensioning? So here from the figure we can see that in absolute dimensioning all measurements are made from a part origin established by the programmer and set by the operator. So now consider this as the original point. So whatever the dimension you are going to do, this is considered as the reference point. So for example, see now he is giving the reference point of the 1000 mm. okay, for this circle. So the reference point is considered as from here to here. So that is 1000 mm. So next, now consider the location, this location, that is a location 3. So we are considered 1, 2, 3 locations. So from here the reference point is considered from this end to this end, that is 1750 mm. So anything which is considered from a part origin, okay, to the desired point is nothing but the absolute programming. So any program coordinates as absolute value in respect to that absolute coordinate system is 0 point. The machine control uses the part program as a reference point in order to position the tool during the program execution. So this is one just example of the absolute programming. Next one, relative programming. Relative programming is identified by G91. That is the part programming. So this is the figure which shows the relative programming. So in incremental programming, the tool movement is measured from the last tool position. The program movement is based on the change in a position between two successive points. So these are the two successive points, that is point 1 and point 2. Here the incremental programming is nothing but the relative programming. So unlike the absolute programming, there is no reference point given here. So here the dimension is considered between the 2 points, that is P1 and P2. Similarly here P2 and P3. Here P1 and P2 is measured as 64 mm, then P2 and P3 is measured as 36 mm. Then in terms of the vertical axis, P3 and P4 is measured as 26 mm. So here difference between the 2 points, okay, the measurement is considered, unlike the origin. Okay, here the programming enters the relative distance between the current location and the next point. So this is the current location and this is the next point. Again, if they move further, this is the current location and this is the next point. So this is nothing but the incremental programming or relative programming. Next, various compensation for the machine accuracy. First one is a backlash compensation. So what is this backlash compensation? Backlash is any non-movement that occurs during axis reversal. For example, if a tool moves in x-axis for 1 mm in a positive direction, after this movement, the x-axis is commanded to move 1 mm in negative direction. If backlash occurs in the x-axis, it will not move immediately, start moving in the negative directions. Next, sag compensation. So it occurs in accuracy movement of a table and weight acting on a slide. So anything which occurs due to the inaccuracy movement of a table or weight of a slide is nothing but the sag compensation. Next, pitch error compensation. Pitch error is nothing but the inaccuracy of a pitch during the length of the ball screw. Next, tool nose compensation. Tool nose compensation is nothing but it is related to the tool tip, okay, tool tip which wears out during the machining process. Next, cutter diameter composition. During programming, it is necessary to consider the cutter diameter composition so that the cutter moves in a correct tool path. Next, tool length compensation. Tool length compensation is nothing but when the program is written, with a standard tool length. Next one, axis and motion nomenclature. First one is the Cartesian coordinate system. So this is a Cartesian coordinate system diagram, okay, which represents the x-axis and the y-axis. Okay, so now what is this Cartesian coordinate system? So it specifies each point uniquely in a plane by a pair of numerical coordinate where exactly the distance part is been identified. So this is nothing but the pair of the dimensions. So this is exactly the distance, okay, which is apart. It identifies the exact distance between the 2 points, that is the x-axis and the y-axis, and these are nothing but the pair of the dimensions. So such part is nothing but the Cartesian coordinate system. So it specified the exactly distance between the x and y axis between the two points, that is a two pair of axes, whether it may be negative or whether it may be the positive. This is nothing but the Cartesian coordinate system. Next one, so this is regarding the explanation of the Cartesian coordinate system. Next one, right hand rule. Here by the figure we can see the right hand thumb, that is a right hand. Here we can see the thumb which is the x-axis, and the y represents the forefinger, then the z represents the middle finger. Here in this, the thumb which represents the x-axis, the fore represents the y-axis, and the middle finger which represents the z-axis. All these fingers are in the 90 degrees to each other, and they move in the positive directions. So this represents the axis movement in the CNC machine. That is nothing but the right hand rule. So which indicates on which directions the movement is to be done. So this is a right hand thumb rule. This is the expression regarding the right hand rule. Next, structure of part programming. So here block of information, numerical control information is generally programmed in a block of words. Each word conforms to a EI standards, and they are written on a horizontal line. If 5 complete words are not included in each block, the machine control unit will not recognize the information. Therefore, the control unit will not be activated. So normally there will be the 5 blocks in which the different coding is written. So if any one block is missing within a certain code, the main control unit doesn't recognize the command. Next, it consists of the characters n followed by 3-digit number ranging from 0 to 999. Next, world address format. The world address are as follows. First one, N001 represents the sequence of number of operations. G01 represents the linear interpolation. X1, 2, 3, 4, 5 will move the table in positive direction along the x-axis. X0, 6, 7, 8, 9 will move the table along the y-axis. M03 spindle in clockwise. Now next, preparatory functions which are represent the G codes. So these preparatory functions are the main functions which are used to develop the part program for the CNC machines. So these are the some of the preparatory functions. G00 rapid positioning, G01 linear interpolation, G02 circular interpolation, G03 circular interpolation clockwise, counterclockwise, G21 metric input, G24 radius programming, G28 return to reference point, G21 return from reference point, G32 thread cutting, G40 cutter compensation cancel, G43 tool length compensation positive direction, G44 tool length compensation negative direction, G49 tool length compensation cancel, G84 cane turn cycle, G90 absolute programming, G91 incremental programming. So here this is some of the standard the codes which are normally used for the programming of the CNC machine. So here with the help of this code we can program the machine, that is we can get the output for the desired drawing. Next, M code. M codes are not grouped into categories. Although several codes may control the same type of operations such as M03, M04 and M05 which controls the machine tool spindle. Here some of the important codes are given as under with their functions. M00 program stop, M02 end of program, M03 spindle start, M04 spindle start reverse counterclockwise, M05 spindle stop, M06 tool change, M08 coolant on, M09 coolant off, then M30 end of tape and rewind or main program end, M99 end of the sub program. So these are the some of the miscellaneous functions which are used for CNC part programming. Next, fixed or cane cycle. A fixed cycle is a combination of machine moves resulting in a particular machining function such as drilling, milling, and boring and tapping. Per program, one cycle code number as many as distinct movement may occur. So if you program one time, it may travel in any distance as possible. This movement would take a block of program made without using the fixed or cane cycle. The corresponding instruction of fixed cycle are already stored in the system memory. So once the program is done, it is stored in the system memory. So that same memory can be used while doing the next programming. Next, subroutine. The subroutine is the portion of a program complete in itself which is stored in a computer after programming once. So this is the portion of program. So once the program is written, it is completely stored in the memory. It is called the required data when required again in the program. So when this data is required, the data is fetched from the memory. Next, circular interpolations. So the figure shows the circular interpolations. Here you can see the I and Z axis, then X axis, then Y axis, then the start point, the center, then the end point. So circular interpolation means the movement which moves in the circular directions. So this is the start point. You start moving to the end point along with the central axis. Okay, the parameter of the center of circle are designated by the I, J and Z. Okay, and K which represents the Z axis. So that is nothing but the depth. Okay, so here this represents the circular interpolation. In this, the command cutter to move existing point to the target point along the circle are in the clockwise direction. So this is the clockwise directions from the starting point to target point. There is the movement. Next, rapid positioning. So here the figure is clearly understood that okay, this is command to cutter to move from the existing point. So this is the existing point to the target point. So this is the target point at a fastest speed. So here from here this point to this point, it moves with a fastest speed so that the machining operation starts operating. So this is the X axis, Y axis and the Z axis. Okay, this is the rapid positioning. Next one, linear interpolations. So here from the figure it indicates that this command to cutter to move from the existing point. So this is the existing point to the target point along the straight line designated by F address. So here from the existing point to the target point, it moves at a straight line. So this indication by the F address. So this is nothing but the linear interpolation. Linear interpolation means the straight line. Next, CNC step turning part program. So here let me see the CNC step turning part programming. So here we can see the simple CNC step turning. Okay, here the maximum diameter is 22. Okay, then it is turned into 21. Last one is 20. Then total distance is about 40 mm. And then this is the reference point, that is 0. Okay, now before that let me begin with the writing the program. Okay, now first one, N01, M03 and S2000. Here N is nothing but it indicates the numerical, that is carrying step by step. M03, here the M indicates the miscellaneous, that is the spindle start, that is the clockwise. Then S is nothing but it is the speed which the spindle need to rotate, that is 2000. Next, N02, G00, X22, Z2. So here N02, as we know that it is nothing but the line indication. Then G00, here the G00 nothing but the rapid positioning. In this rapid positioning, there is no movement, that is the tool movement contact for the workpiece. Then X axis 22, then Z2. Here one thing you should keep in mind, anything which moves in this direction is considered x-axis, and the reverse direction is nothing but the negative. So here from this direction it is positive, and there it is nothing but the reverse direction, it is the negative. So here x22 and z2, here z represents the feed, that is the depth of the cut. Okay, now x22 and z2, now we see exactly where the position of the tools comes for this line, that is the x22. Now consider that tool is in this position. Okay, now if you want to move an x22 and z2, okay, when you give this command, the tool comes exactly, okay, in this positions, that is straight in between this line, that is a x22. So this is considered as the x direction, that is x22, then the z2. Here from here it is a middle 0 0. Okay, from here it comes to the x22, that is in the x directions, then the z2. Next, N03 G01 X21. G01 means a linear interpolation. Here you are making the tool to touch the workpiece, to make some contact within the workpiece and cut the material. That is a X21. So here, okay, we need to bring 1 mm upside. Okay, now here starting the position was here. Okay, now the tool moves 1 mm upside, that is x21. Next, z minus 20, then f80. Here z minus 20 is, this is a negative directions. Okay, then f80 is the feed, okay, in which the tool need to be removed. Now this both direction as a 10 plus 10, it is 20. So near here from it is 0. Now we need to form this step. Okay, now here what happens, here z, so when you give z minus 20, that tool moves from this position to this position. Okay, that is a z minus 20. Okay, it is 10 plus 10. So this is a z axis, that is a negative axis. So now what happens here, okay, now this much amount, this much, so from here to this much amount portion of the material is removed. Next, G00 x22, then z0. So here from here we need to bring back to the positions. So to bring back the positions, so this command is given so that the tool comes in this positions. Next, G01 x20. Now we need to consider this portion. Okay, now G01 is the linear interpolations and x20 the tool movement in the x20. Next, z minus 10 f80. Now we need to get this step turning. So what you are doing here, you are giving z minus 10, that is the negative directions, and the feed is in the 80 mm. So here next what happens, the tool comes in these positions, removing the amount of the material. Now this need to be brought backside. So here G00 rapid movement, then x22, then z2. So now here after this the tool comes directly and settles it. So this is the, okay, then next N09 M20. M20 means the end of the program. So this is one of the simple program for the CNC step turning operations which need to be performed. Okay, next, CNC milling part programming. So here this is 100 by mm, 100 mm by 100 mm. Okay, then this is a circle of a radius 30. We need to write a CNC program for this operation. First step, N01, G21, G40, G90. Here N01 represents the numerical value of that line. Okay, G21. G21 is nothing but the cutting, that is a input cutting composition. Okay, cutting composition. Next one is a G40 is nothing but the cutting composition cancel. G90 is nothing but the absolute dimensioning. Okay, absolute dimensioning. Next, N02, T02, S2000, F0.05, M03. Here T02 represents the tool which the specific tool need to be selected. Then S2000 represents the speed, and F represents the feed, what feed rate. Then M03 means a spindle start in the clockwise directions. Next, G00, X00, Y00, Z05. Here G00 nothing but the rapid positioning. X0 we are not giving any movement. Y0 also we are not giving any movement. Z05 is an amount of a feed which need to be given, that is the 5 mm. Next, G00, X50, Y20, Z05, M08. Here M08 represents the coolant on. So here now this is the x-axis, this is the y-axis. Now giving this x50 and y20. Now here what happens? X50 will come in this position. Then y20 is nothing but it come and touches these positions. So here this is x50, then y20. The next one is you need to give the depth, that is the G05. How much amount of depth it will be removed? It is the 5 mm. Next, now N05, G01, X50, Y20, Z minus 10. So what happens here? G01 is nothing but here it linear interpolation, and the tool touches the workpiece. Then X50, then Y20, then Z minus 10. Then how much mm? 10 mm of depth is given in the negative direction, that is in the downward directions. Then next, G02, X50, Y80, Z minus 10, R30. Here G02 represents the cutting composition in the clockwise direction. So this is the clockwise directions. X50, then Y80. Now X50 is this, then it goes on moving up to this, up to Y80. So here this composition becomes the Y80, and by giving the depth of cut as a minus d, so as to obtain the radius 30 mm. Next, now X50, Y20, Z minus 10, R30. Here this is nothing but the x-axis. Okay, then again it is going to be back to the y-axis, that is 20 mm, then Z minus 10, then R30. Then M05, here M05 represents the miscellaneous functions, nothing but the coolant off form. Then M09 is nothing but the spindle stop. Then M09 is the program stop. So this is a simple exercise regarding the CNC part programming, where the circular pocketing is done. Next, most likely questions for the examinations. So there are 7 set of questions where the students need to be focused during the exam point of view. Thank you.